Hello guys, welcome to the channel Mind Physics, and today we have come up with some few important questions of H.C. Verma. In this video, I want to discuss with you two important questions of the book H.C. Verma. As you all know, H.C. Verma is a well-known writer in the terms of engineering. His physics books are very nice, and so today we have two questions, one on the topic of pulleys and second on the topic of rotational motion. First, we are going to discuss about the pulley quotient, and the question, as you can read, is find the reading of the spring balance in the figure. The elevator is going up by g by 10. The pulley and the string are light and pulley is smooth. So you can see that here there is a spring balance, and from the spring balance a pulley is connected, on which one side there is mass of 1.5 kg and other side it is 3 kg. The pulley, I mean to say the lift, is going up with the acceleration of g by 10. So first in this question we will have to keep some things in mind. First we have to keep the formula of tension. That is when for this one the tension will be less, for this one the tension will be more. I mean to say that the tension will be equal on the string, but for this one it will be m1g minus t, and for this one it will be t minus m2g. So, and g by 10, do not consider this as acceleration, because how much ever the lift goes up, this will be always acting downwards. So this is a thing, you can say this is a tip that you have to keep in mind. So without wasting our time, let's start doing our question. So first, let's mark our terms. Let m1 equals to 1.5 kg, m2 equals to 3 kg. Acceleration is unknown. So first we'll use the formula. As you all know, I'm writing on the formula here. When mg is less, the formula is ma equals to t minus mg. When mg is more, I have written a formula here. Second formula, when mg is more, then it is ma equals to mg minus p. So for m1a, that is 1.5 into a, we can write it as m1a, as this will go up. This is the time when the body is going up, and this is the time when the body is traveling down. So for 1.5 and other side is 3 will go down and 1.5 will go up, because this 3 kg is heavier than the 1.5 kg block. So the formula for 1.5 kg will be the first one, that is m1a equals to t minus m1g. It will not be only m1g here. Yes, this is the thing that you have to keep in mind. It will not be only m1g, but it will be m1g plus g by 10. Here g by 10 is added because I have said that it is going up with an acceleration of g by 10, but I have also mentioned that g by 10, how much ever up it goes, it will always be acting downwards. So with this, g by 10 will also be added. So now we have to just let us now, without giving these values, let us consider this as equation number 1. And similarly, for the second equation, that is for the 3 kg block, it will be m2a is equal to m2g plus g by 10 minus t. This is our second one. Now what we simply do is we add these two terms. We add the first and the second equation. After adding, we get a m1 plus m2 equals to t and t will get cancelled out, g plus g by 10 and inside the bracket we have it's m2 minus m1. Now here will simply be replacing the terms with the original values. M1 will be 1.5, M2 will be 3 kg, and G will remain the same. So first you note this much down, then I'll erase it and I'll solve it further. You can pause this video and note all these terms down if you have not written it, because I'm going to erase it. So let's keep this one alive, because let's keep this one remaining, because this is the main formula upon which we'll be going to solve this question. And as you know, this is equation 1 and this is equation 2. Note down both the equations. So as we had it, A M1 plus M2 equals to G plus G by 10 M2 minus M1. So M1 plus M2, that is 1.5 plus 3. G plus G by 10, it will be 11G by 10, and M2 minus M1 are here M2 minus M1, that will be 3 minus 1.5. The whole part becomes A into 4.5 equals to 11 G by 10 into 1.5. We take GR here and 4.5 comes to our RHS, which means A by G equals to 11 by 30 into 1.5 into upon 30 into 4.5. 1.5, so it's not 30, here it's 10. 1.5 and 4.5 gets cancelled out, that is 3. So we get the ratio, that is, I'm writing the ratio here, A by G equals to 11 by 30. Okay. So what we now do, using this formula, we will be deriving the tension. We'll first be deriving the tension. So coming back to the question, we had the ratio, that is A by G is equal to 11 by 30. We have derived it, and the first equation, that was M1 A is equal to T minus M1 G plus G by 10. So from here I'll be getting the value of tension. T is equal to M1A plus 11 M1G by 10. 11 M1G by 10, because G plus G by 10 is equal to 11G, and multiplied by M1 will be 11 M1G by 10. Then we have one more formula here, that is reading of spring balance. For this, the formula is, it is equal to 2 into tension upon G. This is another formula that has to be kept in mind while solving this question. So 2T upon G. Now what we simply do, we put the value of T. So we had the formula 2T by G. 2T by G means 2 by G, and T means M1A plus 11 M1G by 10. So on expanding this, it becomes 2 M1A by G plus 11 M1 by 10 multiplied by 2 G by G. G and G will get cancelled out. Now A by G, we have our here A by G. A by G means 11 by 30. So on further solving, we get it 2 into value of M1 is 1.5 into 11 by 30. That is the ratio of A by G. So I write 2 into 1.5 into 11 by 30 plus 11 into 1.5 into 2 upon 10. So now what we do, we simply solve this part. After solving this, we'll get the answer as you can see here, the answer will be from here 1.5 and 30, that becomes first before cancelling 1.5 and 30, we cancel out 2 and 30, it becomes 15, and after cancelling 1.5 and 15 it becomes 10. Okay, and now here 2 and 10 gets cancelled out, that becomes 5, and here 5 and 1.5 gets cancelled out, that becomes 0.3. So it will be 11 by 10 plus 11 into 0.3. If you did not get this part, you can solve it on your own and you will get this result. So 11 by 10 means 1.1 and 11 to 0.3 means 3.3. And 1.1 plus 3.3, as we all know, it is, I'm solving down this part out here, 1.1 plus 3.3 will be 4.4, and the units will be kg, because the tension, because T means a value of that is MA, and G also means separation. So A and G, the units are same, they get cancelled out. So we have the only remaining unit is mass, that is its unit is kg. So our final answer is 4.4 kg. After adding 1.1 and 3.3, we get the answer as 4.4 kg. This was the solution to the first question that is being discussed today. Please note it down, and then we'll be discussing the second question also. So guys, this is our next question, and the question is, particles of masses 1 gram, 2 gram, 3 grams, continued 100 grams are kept on mass 1 centimeter, 2 centimeter, 3 centimeter, continued 100 centimeter, respectively on a meter scale. Find the moment of inertia, MI, moment of inertia of a system of particles about the perpendicular bisector of the meter scale. Which means we have masses from 1 gram to 100 grams. Okay, and they are kept on mass from 1 centimeter to 100 centimeter respectively, which means on 1 centimeter it is 1 gram, 2 centimeter 2 grams, 3 centimeter 3 grams, and so on till it reaches 100 centimeter 100 grams. Now they are asking us to find out the moment of inertia, where at the center of the scale, which means at 50 centimeter, that is because they have told us the perpendicular bisector. Perpendicular bisector is such a line that perpendicularly divides any line into two equal halves. You must have studied in 8th or you can say 7th standard maths. So first, if I draw this line and consider this as a scale, so we consider this as a meter scale. And one thing is also important to keep in mind, that they have not given any measurements of this scale, any width, any mass, etc., etc. So we'll consider the scale of negligible mass, or you can say weightless, massless. Now I have a meter scale. They are asking me to find the moment of inertia from the center. At this point, what will be the moment of inertia? This is the question. So I can mark this as 1 centimeter, 2 centimeter, 3 centimeter, and continue till this last point will be 100 centimeter. So at 1 centimeter I have 1 gram, at 2 centimeter 2 gram, 3 centimeter 3 grams, at 100 centimeter I have 100 grams. This is the diagram. So first what I'll do, I'll find the moment of inertia of this total system of particles. So for this I'll just consider an axis at the end, or you can say at the tip of the scale, because at the tip we all know that if we calculate the moment of inertia, it will be for the total system of particles. Now what is the formula of moment of inertia? It is I is equal to mr square. Okay, the total moment of inertia will be summation of mr square. Now here one more tip. We have seen that when mass is 1 gram, what is a centimeter? 1 centimeter. Okay. When mass is 2 gram, what is a centimeter? 2 centimeter. Right? So when mass is n gram, what is centimeter? N centimeter. Similarly, mass, let me consider this mass as n. So what will be centimeter? N centimeter square. N multiplied by n square. It will be summation of n cube. And what are the limits to this? It will be I is equal to 1 till 100, because our last value is 100. Then using the sequence and series formula, what is the formula for summation of n cube? As you all remember, it is, I'm solving this part out here, it will be n plus 1 by 2 whole square. We all know this formula. So what is our n? Our n is 100 centimeter. So what I do, I simply put this value. It will be 100 multiplied by 100 plus 1, 101 by 2 whole square. This will further become, I'm solving this part out here, it will become 10,000 multiplied by 10201 upon 4, that is 1020104 times by 4, and it is 2550 gram centimeter square, which means you can approximate this value. This is the value. You can approximate this to 2.55 into 10 to the power 7 gram centimeter square, which can be further simplified into 2.55 kg meter square. So first we have our total moment of inertia. Let me write this down over here. So at this tip, the moment of inertia was 2.55 kg meter square. Okay, our one part of this question has been solved. Please note this down. I erase it and we'll continue our solution. You can pause this video and note this one down. Now, after calculating the center of mass at the tip, what we do, we find the radius of center of mass, RCM. Now, what is the formula for RCM? It is RCM equals to MI RI upon M summation of MI RI upon summation of M. So, similarly, as I had already mentioned, for n centimeter it is n grams. Now it will be RCM equals to summation of n multiplied by n upon summation of n, that is summation of n square upon summation of n. And as you all know, the n is still 100 from 1 to 100. What is the formula of summation of n square? It is n plus 1, 2n plus 1 upon by 6 upon n plus 1 by 2. This is the further solution. And when you solve this, n plus 1 and n plus 1 gets cancelled out. 2 gets cancelled out, which then becomes 3. So the final one is 2 n plus 1 by 3. We have to just put the values. 2n means 2 into 100, that is 200. And plus 1 means 100, 200 plus 1, that is 201 by 3, which is equal to 67 centimeter, or you can say it is equal to 0.67 meter, which means the center of mass of the system of particles, if this is considered as 50 centimeter, because we have to find it as a center, this is 50 centimeter, then if one more axis is drawn for the center of mass, this total part is, erasing this part, this total is 67 centimeter, and this part is 50, it is 67 minus 50, that is 17 centimeter. So here we have two centers, that is 50 centimeter as well as 60 centimeter. But now what we do, we find the total mass of the system. The total mass of the system has to be found out, which is summation of n, because if I have considered as n masses, that is 1 to 100, summation of n, I equals to 1 till 100. This is for the total mass of the system. It is summation of n, that will be n plus 1 by 2. Now we have to just put the values of n, that is 100 plus 1 by 2, it is 100 into 101 by 2, it is, and if you solve this, you will get the answer as 5050 grams, or you can say this is as 5.05 kg. This is the total mass of this whole system. The total mass is 5.05 kg. Now we have two radiuses, that is, first one is 67 centimeter and the second one is 17 centimeter. Then let us consider this one more. Let us consider just an initial center of mass, initial moment of inertia that we all know. We all consider as I naught. So first, let me clear it out. I1 is 2.55 kg per kg meter square. Okay, we have to find out I2, that is at the center of mass, at the center of this key, that is at 50 centimeter, has to be found out. And we have two radius of center of mass, that is, first one is 67 centimeter and the second one is 17 centimeter. That is from the center to the radius of actual center of mass. Now what we do, we use the parallel axis theorem. As you all know, as you all remember the formula of parallel axis theorem, that is going to be used. So please note this one down and I will clean it, so we will solve the final phase of the solution. Now let me consider R1 equals to 67 centimeter, that is 0.67 meter. This is the actual center of mass, that is, I mean to say, radius of center of mass. Similarly, I1, that is the actual moment of inertia, it is 2.55 kg meter square. Okay, Then after you have got all these, now we have R2, that is 17 centimeter, or you can say 0.17 meter. I'm taking this as R2 because if I'm going to find the moment of inertia at this point, I'll be considering this as the tip, and the distance of this point from the distance of the actual radius of center of mass. Why I have done so? Let me explain this. For actual center of mass, we considered the moment of inertia at the actual tip, that was at the end, and we found out the distance, from the radius of center of mass. Okay, now I have to find out the moment of inertia at 50 centimeter. So considering this as the tip, I'll find out the distance from the radius of center of mass, similarly that I did for this. Okay, now R1, R2 and I1 have been found out. Let me consider I2 equals to question mark, which means I have to still find it out. Now using parallel axis theorem, I1 equals to I naught plus m R1 square, I2 equals to I naught plus m R2 square. If we subtract these two equations, we get I1 minus I2 equals to m R1 square minus R2 square, that is 5.05. I1 minus I2 equals to 5.05 into 0.67 square minus 0.17 square. If you solve this out, you will get the answer as I1 minus I2 equals to 2.021 kg meter square. After solving this whole part, this is the answer. You can solve it because you have time. You can solve this part, and this will be the answer. So from this we get I2 equals to I1 minus 2.021 kg meter square, which means I1, as you all know, is 2.55. It will be 2.55 minus 2.021 kg meter square, and after you subtract the value, the answer will be 0.429 kg meter square. This is your I2. This is the I2, you can say 0.429 kg meter square. This is the answer that you have to find out. Means I2 at the center of the scale, the moment of inertia is 0.429 kg meter square. Let me tell you why the distribution of masses is not considered equal. Because if you consider this, if you are thinking that I would have taken this as the radius of center of mass, then you are completely wrong. Because if you see that the masses are distributed 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, it is 1g, 4g, 3g, 2g, and etc. etc. So first, if you are considering this as a center of mass, then I will give you one tip. First, find out the summation of masses from 1 centimeter to 50 centimeter, and then the summation of masses from 51 centimeter to 100 centimeter. You will see that the sum of the masses are not equal, which means 50 centimeter cannot be considered as the radius of center of mass. After this solution, you get the answer as 0.429 kg meter square. So thank you for watching this video, and if you have liked it, just subscribe our channel for more videos and press the bell icon also. And this was our 2 questions from HC Verma, and we'll be coming up with further videos. Till now, goodbye and take care. Thank you and thank you very much.